This is every challenge question from the textbooks, part 6. It's the straight line chapter. So start off with a very gentle question. B0 is over here, 0A is up here. Gradient goes through here, it's a negative gradient. Obviously, it's A over B, rise over run, so that's fine. Put that into y equals mx plus c. You know c is A immediately, so that's why it's quicker to use y equals mx plus c, I guess, here. Times the thing by b, and then move the ax over, and you end up with the answer very easily. Good. So the next one then says the formula of this. Now, here we can use the formula y2 minus y1 over x2 minus x1. So cool, that's just a formula that's in the book. It's very useful sometimes if you can't be bothered to draw it. So the general equation can be written as this. Let's use the y minus y1 equals mx minus x1 formula here. And the m, of course, is what we've just written down. So we get this. Now, what I'm going to do here, I think, is I'm going to put this bit over here, am I? Yeah. And divide both sides by y2 minus y1. Essentially, sort of reverse cross multiply and put this thing down here. And then just multiply these two things, which puts this thing on the top and this thing underneath, which is exactly what they wanted me to get here. So that's all done and done. Use the equation for part B to find the equation passing through here. So, okay, well, there's the equation. We have x1, y1. We have x2, y2. Let's just put those values into here, and we get this. And yeah, that would mean that's 3. That's minus 7, I guess. No, it's not. It's plus 7, obviously. Cross multiply, and you get this, and then do some stuff. Yeah, that'll do. I mean, this would have done, I guess. That's an equation of a straight line, isn't it? I guess this is as well. And even that, but I mean, it wasn't really. I think I would argue that this should earn full marks. It's the equation of a straight line, right? It's just sure. Anyway, cool. Find the area of the triangle with vertices this, this, and this. I've made an entire video on this that's like 30 minutes long about all the different ways to find the area of a scalene triangle given like 3 coordinates. I'll do this in the most basic way, which is just draw a big box around it and then find the area of the box. Of course, this box has dimensions across from minus 4 to 13. It's 17 across. Its height is 14 to minus 2, which is 16 up. And then you just work out the areas of the three triangles and take away from the area of the big box. So you work out the dimensions of the little triangles just using the coordinates, and then you work out the area of the big thing, and then you take away all the triangles, and you eventually get some answer which is correct. Lots and lots of fancy ways of doing that, which are quite good fun. Anyway, we get to another question here about another scalene triangle, this time with some lines going through the vertices, making right angles with the opposite side. So cool. It wants us to find a bunch of well, it wants us to find the coordinates that all the points meet at, which involves finding the equations of all the lines. So L1, I guess I've said here, is perpendicular to this one, this line here, this side, which has gradient 9 minus 8 is 1, 9 minus 2 is 6. This has gradient 6. So this gradient is negative, sorry, this has gradient 1 over 6, doesn't it? Because it's, yeah, 1 over 6. So therefore, this gradient perpendicular is minus 6 over 1, which is minus 6. And it goes through this point here, 5, 2. So just do y minus y1 equals mx minus x1. And do that for, maybe just simplify it, just do that for all of them. So L2 is perpendicular to this one, which has gradient 9 minus 7 is 7. And then this go across is 4, that's 7 over 4. So the perpendicular is minus 4 over 7. And simplify it up, and then do the same for L3. And those are your 3 equations of the lines. And now we need to show that all 3 these lines meet at the same point. So, okay, set L1 equals to L3, and then set L1 equal to L2, and then set L3 equals to L2. I won't go through an immense amount of work here. I've been pretty lazy about the whole thing. But I'm just saying all of the 3 different combinations you get together, and all of them have the answer x equals 78 over 19. Which, of course, you can then substitute into the easiest one, which is probably this one, to find the y-coordinate, and you get this. This is called the orthocenter of a triangle, just in case you want to do any extra reading about that. Cool. I mean, it's not even really a challenge question. It's just a long question. Like, there's nothing actually difficult about it. It's just really long. Another one here, again, about the orthocenter, it looks like. Don't know why they're asking this twice. I guess there's some algebra in this, so yeah. L1 this time, which was this one here, goes through C0, so that's the y1 and x1 here. Its gradient, well, it's perpendicular to this one, which has gradient b over a, I guess, because this distance is a and this distance is b, defined by that point. So minus a over b will therefore be the perpendicular. You can sort that out a little bit. I just left it as that, I guess. Why did I leave it like that? Does that work? What am I doing? Oh, this is L2. This is L2. This is not, okay, cool. This is L2, which is this one here, perpendicular to this one here, which the gradient here is a bit harder to work out, but it's, I mean, the rise is clearly b, as it was before, and the run across is this distance, which is c, minus this distance, which is a. And then it goes through C0, so y minus, oh, sorry, this one here. Yeah, because it's perpendicular to this one here. So this one here goes through 0, 0, which is why I haven't added anything to those. And then L3, bit of a trick question. It's just a vertical line, so it's just x equals a. Now, it hasn't told me that I need to show that these lines meet at the same point. It just says find the point of intersection of L1, L2, and L3, which implies that I don't need to show they meet at a single point because it's telling me they do. So I'm just going to set the easiest one equals the easiest one, except I'm not, because this isn't of the form y equals. I'm just going to put x equals a into here, or even into here. It doesn't really matter which, and you can just immediately find the y coordinate because you know the x coordinate has to be a, right? Because it's on the line. This intersection is on the line, x equals a. So you can just find the y coordinate by putting this into what either of those do, and then just leave it like this, and that will be the answer. Thank you for watching. Apologies that was a bad recording. I'm a bit tired, but hopefully we got through it, and there's plenty more of these to go, which is why I can't be bothered to re-record that.